section is going to be essentially laying out a grand vision, sort of an overall vision for the retrieval market. And just to start off, I want to do a quick, there we go. Before we jump in, I want to do a quick review of sort of like our goals for the Filecoin retrieval market in 2021. And I'm kind of referencing Juan's slides from yesterday. So as a reminder, we would like to build the first production version of the Filecoin retrieval market. And concretely, what that means is that we want data to be retrievable in sub-second time. We want there to be over 1,000 people involved potentially as retrieval miners, and they're running at least 10,000 nodes on the network. We want to be able to support paid retrievals, not just free retrievals, so that miners can be compensated. And as like a stretch goal, we would love for ourselves to be able to start building mechanisms to redistribute content to meet changing demands. So yeah, those are the goals and they're quite ambitious in my opinion, but I'm excited to embark on this journey. So we shared, yesterday we talked about our goals, and we just talked a little bit about some of the changes that PL is going to be making to our own software to sort of provide some tooling and some foundations from which to build to help facilitate building retrieval markets. And that includes obviously re-architecting parts of Lotus and adding these new capabilities like indexing. And most of these changes have to do with essentially facilitating the core Filecoin flow. You may have heard us say golden path a couple of times. Essentially means like the ability to store and retrieve data very smoothly, so that anyone who wants to store data is very successful in doing so, and that anyone who wants to retrieve data is able to do so ideally sometimes without Lotus at all. So that's what most of those changes are aimed towards that. But a content delivery network actually goes beyond storage miners. We said that the storage miners are really just the core, and they don't cover the edges of a content delivery network. There's going to be a lot more that we have to build to get there. So this talk is mostly about laying out a plan to build this market. And we know we're going to be doing decentralized development. All of you are doing amazing work separately, but also together. And so we have quite a ways to go in just a year. So how do we get from where we are to where we want to go? So I'm going to be laying out an overview of what I see as the components of a decentralized retrieval market that functions as a content delivery network. And we know we all want to build like these small reusable components that can be used by other teams, right? But to do that, we have to have some conceptual alignment on what the different components are, right? And that's the main goal of my talk. Something as a sort of stretch goal for today, I would love it if we can start to agree on what the names of these components are and how we talk about them, right? If we can develop a shared language for how we talk about things, we are going to communicate much faster and much more accurately. As something that I definitely don't think we're going to in any way address today, but is something that would be a great goal for the long term, would be to start to understand these components so concretely that we actually develop API standards for them. And that would be the mechanism by which, we could ensure, for certain that if you build a component to this API, all the other components are gonna work well with it. And that's gonna be a process. I'm gonna throw out some stuff today, but it's mostly as straw man stuff on which to get a lot of feedback. And I also expect that the APIs will mostly emerge from actual implementations as they come into being. And the really good stuff will probably have the most influence. So that's kind of the overview and goals for this talk. And yeah, let's get going. So this talk is mostly going to be based around this thing that's called the Filecoin retrieval specification. About a month ago, I spent a bunch of time looking at a lot of the projects you guys were working on. And I also spent a lot of time talking to Juan about his goals for the retrieval market and doing a little bit of thinking ahead about what's still needed for the retrieval market to operate as a CDN. And I came up with this document that like essentially outlines a rough roadmap for what the thing we're building is and how we get there. I'm gonna be spending a bunch of time reviewing this. At the time I created it, I called it the Filecoin retrieval specification, and I'm not so sure that was the best name, because I don't think we're not really ready for a full specification, and I do not want to personally impose like any hard directions on the awesome work that you guys are doing. I don't know. I sent a whole bunch of private Slacks yesterday, just being like, oh my God, these guys are amazing. They're doing such cool stuff. And so I don't want to do any kind of top-down imposition. It's more of a conceptual framework. The way I would describe it, maybe from PL's perspective, and I don't want to be too authoritative, is it like, this is what we think generally a retrieval market's going to look like. And when we build stuff ourselves, it's probably going to fit somewhere in this framework. But that doesn't mean you have to build things only within this framework. I'm sure some of you might have ideas that we haven't even thought of, and you can do that. You can build those, but if you build components that are part of this and you build them well, you're really setting yourself up for the best chance to like see those get heavy usage in the eventual Filecoin retrieval market. So that's the way I'm presenting it. So at this point, I'm going to go over to the spec and sort of start diving in. And this website is, it's publicly available. It's just a Netlify app for Netlify site for now. And I think I've shared the link with in the chat at various times. I'm going to start with the roadmap, and so so every part of this document essentially has roadmap information on it. And this roadmap stuff is pretty rough, but there's conceptually 3 different milestones that I think are useful to think about, and you'll see them come up again and again. Or actually, I guess there's 4. There's sort of like V0, which is really more an assessment of where we are today, or stuff we're doing right now that's going to be done soon. There's sort of a V0.5. Which is just looking out at stuff we're pretty sure needs to get built very soon in order to unlock other things. And then there's V1, which is the 1 year out. This is the 2020 goal. And this is where we are shooting for like the basics of a content delivery network. There's also lastly a V2 milestone where mostly there's like notes on things that you could do in the future to make it even more awesome. So yeah, that's the basic layout here. This overview page lays things out, and if you want to see actually all of the pieces of the roadmap are gathered on this other page called Detailed Roadmap. I will say that this roadmap probably needs a review. It's already changed a little bit, but it's just to kind of help you get a sense of what we're doing. So what is the retrieval market, right? I'm going to sort of go from like highest level to lowest level and how we talk about this. So at the highest level the retrieval market is a bunch of people and organizations who want to do something, right? They want to interact with this market and accomplish some goal, whether it's to serve content and make money serving content, or get content, or or they want to help other people find content, right? So our highest level is our sort of actual participants, right? Humans with intents, right? We'll call the different intents they might have, we'll call them roles, right? Specific things they want to do. And I've kind of identified 5 different roles that participants in the retrieval market are going to do. There's a retrieval client. That's the person who just wants to get data, right? There's the retrieval miner or retrieval provider. This is the person who is serving data. So these are ones that are pretty familiar. I've identified someone called a marketplace provider, and this is mostly someone who's going to be helping other people discover other people and discover other participants in this network, right? So they're going to be helping them find content. They're going to be helping them look at the reputation of different miners. And they're also eventually maybe going to be helping miners get paid by other people to serve it to clients, right? That actually gets to our next role, which is the content distributor. Now, this is something that does not exist, but is almost surely going to need to exist within the eventual retrieval market. This is the person who has content that they would like to make available to someone else, and they're willing to pay a retrieval miner to make it available and actually cover the cost of that person downloading that data. And then the last person is the person who handles payments. I call that the payment provider. This is essentially in whatever mechanism they offer, they are facilitating payments between different parties. Right now, this doesn't really exist as any kind of an organizational entity. We have a very limited piece of software in Lotus that does this, but eventually you're looking at probably some kind of hub and spoke type, payment channel organizer, facilitator. So those are the high level components. And then within that, the high level roles, I apologize. And then within that, each role, you're in order to perform these roles, like a participant is gonna, they usually are gonna have one role, but they might have multiple, and they're gonna run machines on the network, right? They're gonna be running nodes, and these are all essentially libp2p hosts. And then within that, each role is there. I've defined a bunch of individual components that perform one function in the network, and each role is probably going to have a typical composition of different components, right? So if I am a retrieval client, I'm going to need to run, these three components most likely locally in my own hardware, and I'm going to need to interact with these other roles on the network, and they're going to be running their own. They're going to be running a specific set of components, right? And this again speaks to the ongoing theme of decomposition, right? You have to run less and less to participate in the way that you want, right? And you only run the stuff that you need. And so that brings us to the sort of lowest level. So what's a component, right? So there's I'm going to actually walk through these one by one, but they are individual components that run that do one thing. You can they're the basic building blocks, right? And they generally run in a single process on a single node in the network. And they do not have to run in the same process. Every component, while it depends on other components, should be able to run in its own process and communicate across process boundaries as needed, right? And this is sort of part of the design to allow a lot of composability. Again, these are just mostly recommendations and not necessarily things that everyone has to agree on, but I think it would be, it's useful to strive towards this, right? Notably, not all most of the components in a real retrieval market network do not actually necessarily have to be tied to Filecoin in any way, right? When you look at when I go through these, you'll see there's really only essentially 3 that have any reference to the Filecoin network. And even then it's, potentially they don't necessarily need to be tied to Filecoin. As you read the spec, you'll see that I always sort of note what components talk to what other components, and and I also define an API specification for each component. Again, these are mostly strawman proposals, and I define them with Golang, but they roughly follow the same JSON API format that Lotus uses for its APIs. So the translation to a JSON RFPC API should be pretty straightforward. Cool. Okay, that was a mouthful. I'm gonna start digging in now. Cool. So the first component is a mechanism for transporting data. You can think of the primary example of this currently as GraphSync in the current sort of Filecoin setup. A transport. Specifically, the place this interface appears in current software is a transport interface inside of the data transfer software that essentially abstracts the underlying transport. And while GraphSync is our current one, there's an opportunity to potentially build a much simpler protocol that's close to HTTP. This is something that we are looking into in our own software. it's tricky because you need to be able to verify data as it comes in for most cases, but yeah, but you could potentially have multiple transports. And we also talked about yesterday the possibility of bit swap or mixing grassing and bit swap. So you can think of the transport API as essentially just the thing that moves data back and forth, right? Above that, you have data transfer, which coordinates the transfer. And that means negotiating like the transport mechanism, maintaining a state about the transfer, and coordinating with what we'll call an exchange protocol. I'll go over that shortly, which is essentially the thing that, facilitates payments. Right. And so, the implementation of this right now is Go Data Transfer. The main thing that needs to be, that we'll probably be working on improving is, allowing it to support multiple transport layers. You can see the APIs here. If you look at them, they're going to look a lot like the actual code in Go Data Transfer, though if you look closely, you'll see a few different changes. And these are basically based off of my own estimations of like things that would make this easier to understand for other providers. So the next component I call in this spec, I call it exchange. Now, exchange you're most familiar with it as essentially the retrieval market software and go fill markets. But I think exchange is probably a better description because we could potentially have multiple exchange protocols, not just the one that is in retrieval markets. And the basic goal of the exchange protocol of an exchange module is to facilitate a fair exchange of payment for data, right? Now, this is obviously a complicated problem, and fair exchange, there's a number of solutions, none of them are perfect. That can include stuff like, it can include stuff like having third parties involved. It can include what we do now, which is essentially just a form of optimistic fair exchange. And it essentially just the exchanges is responsible for making sure both parties fulfill their obligation, however that's implemented. And again, if you look at the interface here, you're going to see stuff that looks pretty similar to parts of Go Fill Markets. There's a few changes to kind of facilitate the idea that it might be operating in a separate process, because that might be important. And yeah, that's what the exchange mechanism does. Exchange, in turn, needs to communicate with some form of payment. And that's what this payment channel manager is. That's what I'm calling it for now. But payment channel manager, this is really based off of the early stuff, but I know that a lot needs to change, right? Because eventually a payment channel manager is ideally actually running an entire website that is doing some kind of like hub and spoke type payments, right? So this is but essentially the payment channel manager is responsible for setting up payment channels and creating vouchers and communicating with between facilitating the payment part of things. Now, the payment channel manager, in order to do this, is going to need to talk to wallets for each party, right? So again, we're seeing pretty common components, so common things that exist already. This one's based off of Lotus. And then in order to do all this, there's a component to interact with the Filecoin chain, right? Now, this is essentially just an abstraction of what we call the Lotus Lite API, which is just the parts of Lotus that interact directly with the chain. So that covers all the stuff we know. Most of this is really, well-known stuff. I'm going to start getting into some of the newer things that get into a lot of the projects that you all are building. So we have the one that we've started to talk about is some kind of a content routing interface, right? So we know we need to have something that allows us to basically find content on the network. And this interface that I've described here is largely based off of the Find Providers API that's in that's sort of like already in IPFS. But I've sort of started to add others, and the assumption is that this would be built off of the smart records that Petar gave a talk about yesterday. Eventually, and we want to make sure that, speaking to what Will was just covering, that it speaks to both, that it can speak to multiple types of content routing systems, whether it's the DHT or indexers or whatnot. Cool. Another thing that you guys have heard a lot about is a reputational index. Again, this is something that will allow you to query it to get information about the state of miners. And then the last two components that are like probably very new to you. Sorry, can I get a quick time check? How am I doing on remaining time?
10 minutes.
10 minutes
still.
Awesome, perfect. Oh, I'm right on time. Cool. I can just slow down and yes. Okay, and then the last two components have to do with the idea of people who want to actually pay to distribute content. And again, you'll see on each of these pages, there's a little bit of there's a confidence level, right? And like, it's basically me saying, I think this is, I know vaguely what this looks like, and it mostly has to do with whether the software is built, right? I describe this concept of a content bid index. This would essentially be some kind of a market for making offers and placing bids on content that you wanted to store. The basic idea is that someone who, I believe it's the people who are, yes, the content distributor would place a bid saying that they have this content that they're willing to pay this much to store, and then a retrieval miner would query the index and like get those bids, and then make and then essentially they could make offers to actually store that content, or not store it, to serve it, to retrieve it, because it's not provable storage in the same way that storage mining is. And then I have this notion of a content distribution API and distribution component. And what this would do would be to facilitate essentially it would sit on top of data transfer, and it would negotiate the distribution of content from a content distributor, someone who wanted to have content served up, to a retrieval miner, someone who would actually do the serving. And there's an API here that's quite similar to the exchange protocol. And then the last step of the exchange will actually be probably a little bit complicated, because we're going to need to have a transfer from miner to client, while an exchange actually facilitates a payment from distributor to miner. But I think that these are sort of like, this is going to be an important functionality if we want to call it a CDN. This is what people often expect, where clients are often not expecting to pay for the content. Cool. Yeah, I just want to talk, the last thing I'll talk about briefly is just a little bit of thinking about what the big roles are going to look like in terms of software and then over the course of the next year. Probably the one that is well, you heard a little bit about what we're doing with Lotus, which will probably make be the initial changes that lead towards that matter for folks who are doing mining. Now, eventually, what we're probably going to do, what we would like, is that people should be able to operate as retrieval miners without operating as storage miners, because obviously storage mining is a big bar to get over, and we'll see what that looks like. By breaking up parts of Lotus, we're sort of setting up the beginnings of that. It was interesting to hear that maybe Estuary is a potential retrieval miner, piece of software. There's sort of like a number of possibilities here. This isn't like super mapped out. It might be that IPFS is itself potentially a retrieval miner, or Go IPFS is potentially a retrieval miner. For the retrieval client, we have kind of a much more detailed plan. Our goal is most likely to make Go IPFS a retrieval client at some point in the future. And there's a bunch of steps to get there, and I want to just briefly jump back over to this presentation. Let's see. Goodness, sorry, my presentation is hidden under the Zoom. Let's see. Let's see if this will go forward. Yes. We're going to have to do some re-architecting of IPFS in order for it to be able to retrieve. This is like my napkin math re-architecture, so please don't hold me to it. Also, like, I don't want to like present this as something this like hacked up re-architecture without running it by a team who's sort of like the main person. But what we're right now, our IPFS does most of its operations directly through Bitswap. Bitswap manages a whole lot in IPFS, and among other, like it fetches content, but it also like tracks peers, like as you're trying to like fetch, if you're fetching a DAG of content, it tracks like what are the peers that responded for other parts of that DAG. It's responsible for that. It's responsible for going out to the DHT. It's responsible for providing CIDs to the DHT. So when we look forward, what we're going to need to do is like, we need to get all these things that are under Bitswap, like out of being under Bitswap. And that probably means that we're going to have some higher level interface that is going to coordinate all this. I've, for the time being, put this thing called the fetcher there, which is possibly going into IPFS soon, which is mostly aimed at doing doing fetching based off of IPLD selectors, which are very similar to retrieval. But we're going to need to, the first step is we're going to need to find the providers, and our finding of providers, again, we're going to have to add this layer of indirection that allows us to go to either the DHT or potentially to some sort of indexed gateway, and look for content in both places. And then we're going to have to make some kind of a decision about whether we're going to use our standard, IPFS Bitswap type retrieval, or if we're going to go over to and try to do a Filecoin retrieval with data transfer and most likely graph sync initially. We are most likely going to start very much focused on free retrievals. We are not going to attempt to do paid retrievals in our first run because, among other things, we are most likely, when we do support paid retrievals, we will probably have the payment mechanism operating in some kind of a separate process, so that, because there's some, we don't know for sure yet, but I think that one of the guarantees we've always made with IPFS is that it's not going to incentivize per se Filecoin over other protocols. And so most likely data transfer will be, you can imagine a little exchange module somewhere over to the left of data transfer, operating across a process boundary and managing the actual payment part. And so then you just get a few different other changes. We're gonna have to move the tracking of peers out from under Bitswap, and we're most likely going to need to move the providing. I would probably move it all the way up to the top level of IPFS. So this is some stuff that we don't. It's not necessarily going to look like this, but it is something we're definitely going to be looking at, because one of our directions is to probably have Go IPFS be a retrieval client, especially for free retrievals initially. So yeah, so those are all the different things. I am not going to get too deep into, I'm trying to think if I should go too deep into some of these other things. Again, our hope is the goal for payment providers on this network is to slowly evolve to be actual payment providers who manage hub and spoke payment channel systems or something else, we don't know. And then our goal for, and then the idea is that for, I grouped the idea of reputational index, the idea of a content routing index, and potentially this bid index into a single person. It may not be a single person, that might be multiple people, but yeah, I think I'm going to stop because I've talked myself blue. And I imagine the chat is full of questions saying that makes no sense. So I would love to read what those are before I continue. So.
Thank you so much, Hannah. So yeah, what's new content here? We have a question on chat, and given that we allocated a little bit of extra time for this specific Q&A, maybe we'll take that question and then open up the room for people to just raise hands and do a live discussion rather than a direct Q&A. So the question is your retrieval client a node in the network or a library that an application could statically link to?
I had been noted, in order to operate as a retrieval client, you need to be running a libp2p node. When I say node, for me, node means a libp2p node, as in you have a network address. So in that sense, it is definitely a node. Now, it could be running within Go IPFS. which is obviously its own application, or we could get to the point where it's a standalone library that other people could integrate. I know for myself, the long-term goal that I would love to see for a retrieval client is something that can run in the browser, because fundamentally, like, what people are going to want is to be able to retrieve data from in their web browser. So it's a little hard to. I think the initial goal is to just get it to IPFS, which is like its own challenge. And we definitely want to be able to interoperate between, you know, these like free retrieval and free Filecoin retrieval and IPFS. So that in and of itself is a big challenge to figure out. And so it's good. We're probably going to spend some time on that. I know that though also like that, you know, some of the stuff that like Mael is doing is really like quite impressive as well, and might slot into some of these things. And then the one other thing is that one thing that I would see operating on its own and not maybe as another node on the network, or as, you know, but also still within some kind of library is the like payment mechanism when we get to that. So yeah.
Thank you. We have another question in chat. Hey, Peter, do you want just to say the question yourself?
Yeah, it says, is this framework compatible with coordinated W3DT Golden Path designs? That is the intent. I do not believe there's anything in there that is operating differently, and I've mostly synced up the names. They originally were some other names. Yeah, but so the Golden Path is again like focused on retrieval from storage miners, and much of that specification actually matches the things that we want to do in order to support Golden Path, and that's at least from the standpoint of Protocol Labs, that's probably the first thing we're going to be working on, including IPFS as a retrieval client is currently sort of part of the designs for, you know,
I'm just like asking like a super practical question, because I'm not like in the flow of the non-ResNet lab world, but basically like the Golden Path is like this like high architecture, sort of high level architecture design of all the software components, and you have like specific interface designs. So I was wondering if essentially these interfaces are going to be the interfaces in the boxes of the Golden Path components, basically.
Yeah, I wouldn't necessarily say they will be those exact interfaces. Again, the interfaces are looking pretty far forward, and like I would not live by them yet. They are, you know, like you'll see on the pages for the components that they have a sort of state. So like there's one that's called, you know, the one that's Filecoin chain, its interface is marked as like, you know, I think it's marked as like close to being done or something. And that's only because it is literally is the API of Lotus, right? So, or the API of a small part of Lotus. And so I don't see that being potentially that changing much. Now, how you call that might change, because like that currently that interface is part of a monolithic Lotus node, and that may be split out. And that's actually already split somewhat, because that interface is part of the Lotus API that's in so-called Lotus Lite, which is this version of Lotus that does not actually sync the chain, but talks to another node that does. So yeah. Yeah, I mean, I was mostly those interfaces. The one thing that is true about them is that they do talk to each other, and they are compilable. But I am also not like, you know, under the illusion that you know, off like, you know, just pulling stuff out of thin air that they're the right ones exactly. Yeah. Cool. Okay, next question.
I think we have Thomas.
Hey, yeah, it was kind of hard to write everything, but my question is, we've had kind of conversations in the past around how to augment IPFS and build, you know, modular ways to kind of, you know, bring in your retrieval market or your service. And I'm kind of still wondering where that conversation is, because it can become quite hard for, you know, end users to run all bunch of different services. And so how does it happen where you're running a whole bunch of nodes on your computer? Where do you see this going in the future?
Yeah, for sure. Well, so up to paid, up to just as a starting piece, up to paid retrieval, up to the point where you're paying, you're still within a single node in process. But I totally, sorry, I should rewind and just say I totally kind of agree with your point. There's like a larger question about like how does IPFS become more composable or pluggable. There is a plugin API, which obviously you're quite aware of because you guys are working with it. But I think it would be interesting to, I don't know, we have not done any kind of like an IPFS architecture audit, I think in some time at PL, and we may need to take a look at that before we start messing around with the guts. So.
I wanted to include just a quick note here around nomenclature, because I think it's really important given kind of how the Filecoin software ended up developing. In order to ship last year and so on, all kinds of important connectivity layers and because the software approach was just different, it ended up yielding pieces of software that didn't talk to other parts of the system as well as we could. So we ended up with like an accidental division between, say, like the Filecoin software stack and the, like, say, Go IPFS and JS IPFS versions of the world. So I think when most people have been calling IPFS here, I think people are meaning Go IPFS specifically, like the software distribution. The IPFS system is as like a larger scale thing. We should be thinking about it as some network-oriented way to distribute IPLD data. And so like that's super general, right? But like that is sort of what IPFS is about. And so that means things like Lotus node is an IPFS node. It just doesn't talk to Go IPFS as well as it should. And so what we're going to do about this to kind of help reduce the confusion, we're going to rename Go IPFS and JS IPFS and give those implementations names other than IPFS, so that when people say IPFS, they don't specifically just mean Go IPFS. This is kind of like what happened to the HTTP servers back in the day. They were called HTTPD, and it was a massive confusion because when people said, "Hey, run HTTP," they specifically meant like a particular binary, and then that ended up changing with the name Apache, and then later on Nginx and so on came in. So we're kind of like in that stage here where, hey, Go IPFS and JS IPFS will get renamed so that we can think about them more clearly. And so then pulling and distributing things from Lotus and Forest and whatever Go IPFS ends up being called, or PowerGate, or retrieval mining nodes of various different types, all of these should have very simple interface layers that where they can talk to each other very, very smoothly. So the ideas of pulling a bunch of this thinking into the Go IPFS implementation sounds great. I think it depends. One of the important constraints in those implementations is that they remain kind of like payment neutral to some extent. And so there might be constraints there around saying, hey, there should be one distribution of this that doesn't require paying through some particular market. However, in any place where there are vouchers or things like that, then they would work just fine, right? And so for most of the retrieval, most of the CDN style use cases, the publishers are going to be paying the bandwidth costs, and they're going to be kind of giving vouchers or something like claimable vouchers or some way of accessing the data to the end user. So like the retrieval nodes, like the actual browser, the retrieval clients, right? The actual browsers or web pages and so on. And those can be just JS IPFS nodes potentially. It's not really clear that they can't be. And so it's like this kind of evolvable layer of just getting into just the concrete interface points that we need in order to kind of move around a lot of this data, find this data, and so on. We want to get to like a very composable experimental place where it's very easy for any team to be like spot a problem and say, oh, actually, all of these things would work better if there was like this type of software distribution, software component here that like changed this data flow, and like that becomes like super easy to plug in across all these different distributions of software. I don't know if that like By the way, give me feedback on chat if like this was confusing. I'm very happy to like go and record a talk like where I go in detail into kind of how we're gonna all this renaming of the implementations and so on. We're also gonna name the DHT, so like, it's very clear like when something is in the current IPFS DHT, what does that mean? That has a name. So it's easy to think about like the different content distribution layers.
Adin does have a question about the extensibility story in chat. Maybe you want to say something about that?
Yeah, it was mostly just saying that I think that separating out, like, you know, clarifying like that IPFS is sort of a more generic thing than Go IPFS helps, but there's a deeper level of like extensibility and like shared understanding of what people are talking about when they say something like supports IPFS, which is, I suspect, a term that if we wanted people to move away from would be quite hard. Right, like
it's like, what do you mean when you say supports HTTP, right? Like you don't mean you run the binary that was used in the 90s, or you don't mean Apache, you don't mean Nginx, you mean there's specific protocol layer where you have like this request reply model, and like you speak HTML and you have like the headers. And so that's what we need to get to with IPFS, is like very clearly defining what and have a spec for the protocol for the exchange of these graphs and how you look for them, right? Like the question of how you find who's got these graphs, that like we gotta define. And these interfaces that we've been talking about today around content routing and supporting these different systems that can give you that content routing is like a key question there, because, and this is sort of fundamental in content addressing. When you deal with content addressing and you want to support applications across the spectrum of, you want to allow data centers to use content addressing within a data center, and you want to allow for like vast amounts of data, like petabytes of data, and you want to allow a mobile phone to use a browser to talk to a website, like those two landscapes to use the same distribution system, they're not going to be using the same content routing model at all. They're going to use a bunch of different style protocols underneath the hood. The same way that sure, they might speak the same HTTP language, but in reality, the servers involved in moving around those requests are very different, and all the networking stack is very different. Like the lower layers of the internet are very different, and so that's the same kind of problem space here, where at the end of the day, IPFS is about allowing applications to model their data with content addressed graphs of hash linked data structures, and making it easy to move these things around and sort of find them. And like the find them part is what a big part of solving all of these problems is, like creating good ways for people to make new ways of finding these things that play well with the rest, where you don't end up with like a fragmented environment that's hard to search, but rather you can explore the space like pretty cleanly. I think this has some good analogs in the HTTP world too. Like DNS services and systems work very differently under the hood, but all of the interfaces and APIs are so smooth now that it's all very transparent. Like people don't think about this, they don't have to deal with it, but under the hood, DNS systems are pretty different.
I guess I was trying to like, maybe a more concrete like example is, you know, Brave says that like they have their you know, you can find things by typing in IPFS:// a thing, and right now it's using this IPFS public DHT to find stuff, but now I want to add support for you know, for what Mile is doing or for what Pegasus is doing, right? Someone needs a way to talk about that in the same way that when I say something is like on the web, it doesn't mean it's on localhost, right? It means, yeah.
Yeah, exactly. So this is what making good content routing interfaces and APIs means. And we're gonna solve this problem well once we have 3 or 4 different content routing systems that need to play together. And a tool should not have to learn 4 different clients, and users should never have to worry about this, or usually should never have to worry about where it's coming from. The software should have smooth pathways for dealing with it.
I guess the other thing that there have been experiments, and I think are continuing thoughts on experimentation of things like, could you have codec extensibility as a WASM module? So a DAG that's using some codec that's not one of the DAG PV or the standard types of ways that we understand data, maybe in that multi-codec gets to point to the data of the WASM module of the way to interpret it. And so there's some things where things can then load in ways. And you can imagine that also for additional protocols for how do I actually then go and get this thing that needs payment? Can I have some way to learn enough to make the request to the DApp so that the provider can do its payment channel thing that it needs in some extensible way? If it's not something where I need to actually pay myself, because once I've got a wallet, that probably is some other piece of software I have to be thinking about meaningfully. But if it's offloading to a CDN, there may well be a way that that can all just sort of happen automatically in an extensible way.
Yeah, I just want to, by the way, I want to identify that I sort of made the bold claim that we were for sure going to be changing Go IPFS itself in my talk. And so that may have created confusion. And it sounds, there's a possibility that this will be within, I think that what we want to do is make sure that if you're running an IPFS client, whatever that is, that you can retrieve from both IPFS and Filecoin. Yeah.
So we'd love to hear from more folks that haven't spoken yet. Any thoughts, questions, things that relate to what has been presented?
Sorry, can I ask a question? Maybe it's not too relevant, but a question about redundancy and data resilience. I know that for now it's up to client, so he has to store data twice and agree with multiple miners, like for 2, for example. But if I'm as a client and I want to store data, this is like a first question for me. Like I want something be trustworthy. Like, did you consider doing this data redundancy and resilience based off CID parts, like pieces, instead of like doing the parts of files and the responsibility of the client? So I don't want to think about it. I just want to store it in like in a red array and forget about it. So this is like looks to me like a feature of a system, like maybe one of the most important one. So I don't have to worry about how many miners do I talk to, and I don't want to be responsible if I choose wrong miners. I just want to store data and forget, and maybe you will cut it into pieces and give CIDs to the pieces and distribute it across multiple miners. And as a client, maybe I don't want to be, I don't know, have an idea how we store it and where and so on. Just my general vision of all the system.
I was going to say, if other folks want to correct me on this, but I think that our belief is that is absolutely something you should be able to do, and is something people will want to do, but it is essentially a concern that is above the level of the blockchain itself, right? That it is not necessarily part of the core Lotus software. So you saw, like, for example, like when we did the estuary demo yesterday, that is like, that's a piece of software that when you say, I want to store this piece of data, it makes a bunch of deals with a bunch of miners just to sort of automatically get that redundancy. And my assumption, I believe, is that we would expect that people will build software that does this kind of, like, whether it's just pure redundancy or whether they're doing some sort of dividing up in some kind of array type mechanism. Is that an accurate answer? Does anyone else who knows more than me want to take it? I only took it because I did the last talk.
Hannah,
Yeah, I think that's.
oh,
go for it.
go ahead.
I was going to add that there's just a large amount of possibility in once you start thinking about redundancy of different pieces and erasure coding and moving things into different places. There's like a whole world of different kinds of pieces of software and design pieces that will come in and become relevant at that point. And I think it's up to these layers to kind of provide both a very good default path for the simple things that people need now and carve enough space for people to go and, as the needs require them, kind of expand into more of those kinds of use cases, right? Like if and there's all kinds of utility that comes from content addressing and like the whole MDN world and content-centric networking world has tons of very good solutions for a bunch of very interesting problems around moving content that all become, or a lot of them become possible to use once you can make these network layers extensible and you have a uniform way of relating the pieces of data and knowing how to find them. I don't know if that as relevant to the question, but the question sort of sparked like where did those groups that want to expand that kind of thing fit?
Yeah. So what I was going to say, So what I was going to say is, well, one, I hope what Hannah says is right. I mean, I think being able to redundantly store stuff is fantastic. So with our retrieval client library that we've been creating, my thought is, or vision is that it'd be great if we could get to the point where we could have this library, say, running on iOS, on Android, in the browser, wherever you like. And you can decide to drop your readme.txt file in and then get it back. And so it can do the storage, it can do the wallet for the payment, and it can locate the data. So I guess when we're thinking about Google Drive, for instance, or Dropbox, you know your account number, so the top level, and then you know the file you're after and the bits of the file you're after. And so you've got that two-level ID, which is how we've tried to structure the whole our system as well. And just to try and get to 2 to the 60, because 2 to the 60 is a huge number. And yeah, maybe it's 2 to the 80, but still, yeah, to try and have that 2 layering. And so I guess I may not have thrown too many questions in, but I'm just trying to work through how our solution relates to the indexer, which is, it feels like that will help work with our provider system, which essentially helps to publish the content that has actually been stored. And then the systems that then the terminology that you've got there, Hannah, just thinking through how that relates. So, but yeah, so I guess I'm not directly having questions here, but I'm just sort of saying that that's where I'm sitting at the moment, is just thinking through exactly how it relates and how this architecture relates to the architecture that I've been thinking about that we could move forward with, which should hopefully help anyone store, just with a little client library that's sitting in an iOS app, or
I mean, so actually, it's a great question. I'm totally happy to try to take this question from other folks, but like from what I know of your stuff, like I would see like your incentivized DHT, that to me is a form of, that's going to fit in the content routing piece, right? And I believe your gateways are the gateways are the things that serve up content, but they actually have they don't have the content themselves, or they're just helping you find the content.
Yeah, they help you with discovery. So essentially, you know your PCID,
Yeah.
and but you've no idea who's got it, and for that matter, how much they could give it to you for.
Yeah.
And so you might find miners, but you also might find local caches of it as well.
Sure.
So
Sure.
someone might be wanting prepared to undercut everyone.
Right.
Yeah.
So that is also a form of content. That's a content discovery and content routing are essentially the same thing. They have a slightly different meaning, but like I generally use only use content routing.
They're not the same thing. There's a very big difference. The difference is discovery is a process of passively finding things, like peer discovery. You're in a network, you don't know who's around, you suddenly find peers. You weren't looking for them. Maybe you were looking for other people, but you just passively find peers. In content-centric networking, content discovery is like you will passively find content. Content will passively be pushed to you. Maybe you were interested in it, maybe you weren't, but you're finding the content. And a lot of algorithms and protocols leverage that passive diffusion of content to then distribute, like to get to like really good solutions, even when nodes weren't interested in it. So then routing is a separate problem, which is I specifically want to go for a specific thing. I want to find a peer, or I want to find a piece of content. What do I need to do to find this thing that I'm interested in specifically? And so like those two problems end up, right now, our interfaces don't really do much with content discovery. We basically just have peer discovery, peer routing, and content routing. But all the content-centric networking world has tons of interesting diffusion-oriented protocols that do the proper content discovery thing. And so I would like, yeah, sorry to interrupt. It's just like
what I should have said is that I was told the correct difference, and so I'm using I'm using the word content routing now. But I believe what you're referring to is also content routing, right? Because you're talking about a gateway node that is going to track where a bunch of content is, right? And so both an incentivized DHT and a gateway potentially operate as forms of content routing. Now you mentioned like the gateways might also have like some kind of a cache of the data. And you might, I don't know if your intent is to like ask the gateway and then ask the miner directly, or to actually have the gateway proxy the request to the miner and then send it all back and or respond through the local cache if they have it. If that's the case, I would describe it as also operating kind of as a retrieval miner, and and that's okay, right? Like it's okay for like things to do both, right? It's mostly about these names. Yeah.
I think we did the analysis of whether it of the attack vectors and whether it made sense to actually have the content come back via the gateway network. And the analysis was that it was actually a dangerous proposition. So doing the discovery of where the content is at a certain price, and then essentially being able to prove that that a provider offered the content at that price, then allows you to find that provider if they end up saying, actually, I'm not going to deliver the content after all. Yeah, so the gateway single hop DHT is all about finding where the content is at what price. Yeah.